In this video we talk about uh, three simple tricks that helps you when you try to select u and dv in the integration by parts formula. So what is integration by parts formula? It is udv equal uv minus vdu. So what we're trying to do is the method is we're gonna select. So the method is select u so that the second integral, that means vdu, is easy to integrate, to integrate. So that's the kind of argument that we're gonna do. So we're gonna make sure that the second integral is easier compared to the first integral. So there are three simple tricks that can help you to do this choice. So the first one is, let's say you have a polynomial, you have a polynomial with functions such as e to the x or some other trig functions like sin x, cosine x, and also maybe some algebraic functions such as 2x plus 1 to the square root, things like that. So if you see these functions with the polynomial, your choice is you're going to select u as the polynomial. So that is the first type. You're going to select u as the polynomial. So I'm going to give you several examples for that. So let's look at some examples. So let's say the first one is, maybe you're going to see x e to the negative 3x dx. So like a problem like that. So according to this argument, your u going to be x, right, and then dv going to be the rest of the integral, that means e to the negative 3x dx. So that is the choice we're going to make in this integral. And also I'm going to give you one simple formula also, like when we have e to the kx, k is a constant dx, and we know that it is simply 1 over k e to the kx plus c. So this may also help you when you try to do the integral. So that's the first one. So let's look at another example. Let's say if you have let's say x cosine some function like 2x plus 1 dx. So if you have something like that, again according to this argument, it says that you have to select u as x in this case, and then the dv is the rest of the integral. So it is cosine 2x plus 1 dx. So that's the choice for the second integral according to the argument. And then let's look at another one. So let's see the third one. How about x 2x plus 1 square root, something like this. So again, according to the argument, you're going to select u as x, and then the dv as the rest of the integrals, that means 2x plus 1 square root dx. So that's the choice for the third integral. So and then also this problem actually you can do using substitution method as well, but if you use the substitution, then you're going to pick u as the inside function. In this case u equal 2x plus 1, but that's a substitution method. But if you do the integration by parts, you have to pick u as x. Okay, so that's the first type. So let's I'm going to say the first class. So let's go to the second type, the second class. We can have polynomials with, let's say, some ln functions or inverse trig functions, or like any other inverse functions like inverse trig, inverse sine, inverse cosine, or inverse tangent, things like that. Some functions, it doesn't matter what function. So we're gonna kind of select, in this case we're gonna select that function as the u. So in this case our choice would be, we're gonna pick this part as the u part. Okay, that's the u function. So let's look at several examples. So the first one is, let's say we have x to the 3/2 ln x dx. So according to this argument, we're gonna select u as the natural log function, and the rest of the function go to dv. So that's the choice we're gonna make. And then how about this one? So if you look at another problem such as x sine inverse x dx. So in this case we're going to select u as the inverse trig function, so sine inverse x, and then dv is the x dx. Okay, so that's the second class. And the third class is what can happen. You're gonna see some exponential functions along with sine and cosine kind of functions. So if you see these kind of functions, what we're gonna do, we're gonna select u as the exponential function just to make it easy. But even if you select the other one, you can work, but this is much easier. So you're gonna select the exponential function as the u function. So let's look at an example. So how about e to the 3x cosine 2x dx. So in this case, according to this argument, you're going to select u as e to the 3x, and then the dv is the rest of the integral, that means cosine 2x dx. And then this can help you. What's can happen, this is like a kind of special integral. What's can happen here when you try to integrate, you can remember you have to integrate this twice. So integrate twice. What's can happen when you do that, the e sine e cosine become e sine, and then the second integral become e cosine, and then you integrate again. So so here what normally happen, you have to get like 2 times I situation. So yeah, so that's a special situation. Okay, and then also, like, when you try to integrate sine cosine function, this one will also helpful. So for example, we have this formula. So if you have cosine kx dx, it is 1 over k sine kx, and then when you have sine kx dx, it's going to be negative 1 over k cosine kx. I ignore the plus c here. Okay, so yeah, so these are the kind of tricks that can help you when you try to do integration by parts.